Hey guys, today I'm going to talk about water treatment and the management of sewage and different wastewater. So let's get started. So since the Industrial Revolution, we've seen a significant increase in the amount of pollutants that we put into the water table. And the main culprits of these pollutants are from agriculture, industry, and mining. And so some of the negative effects that these have on the environment, like we discussed, can possibly be eutrophication, acid decomposition, and specifically for mining, acid drainage and sediment runoff. And so these have a lot of negative impacts and can cause mayhem on the systems that we rely on for food and all sorts of different things. And so these pollutants are coming from two different places, either point source or non-point source pollutants. And the point source is what we're going to discuss a little bit more in depth today, which is related to like sewage waste and that sort of pollutant. And we had briefly discussed the purification of municipal sewage and the three different processes that are used to clean this wastewater. So let's look into that. So here is your typical wastewater treatment facility. And this is a diagram that shows you the different steps that are taken in order to clean our drinking water or the water that we expose of in rivers and different water places. So the first step is primary treatment, and we'll discuss that now. So the first step in primary treatment is preliminary treatment. And how this works is the wastewater is pumped through a screen. And what the screen does is it kind of just removes a lot of the larger inorganic materials that might start clogging the pipes or machineries down the lines. And so what you're really catching with the screen are possibly hygiene products like plastics, and oftentimes rocks or pieces of wood from storm water that may come through the facility. So once it's gone through this screen, it comes into a grit chamber. And what the grit chamber is doing is it gets rid of all the gravel and like heavier sediments that could really cause problems down the line. So let's continue with the wastewater treatment and talk about the second stage of primary treatment. So you might be somewhat familiar with these tanks, and their job is to collect sediment and other suspended materials. So they are regarded as a clayfer in the engineering field, and their job is to collect sludge at the bottom of the tank and scum at the top of the tank. So let's take a deeper look into that. So here is the inside of your clayfer. And as you can see on the top of the tank, you have a skimmer arm. And what the skimmer arm does is it comes around in a circle and it's going to collect all of the suspended particles or substances that you might have, like grease and oil. And those are going to come into the scum trough. And on the bottom, you have your rake arm, and your rake arm collects all of your sludge. And that is going to ultimately go into the digester. And once in the digester, these different pollutants can be taken to a landfill or possibly even used for fertilizers and agricultural means. So that is primary treatment. Let's look at secondary treatment. So secondary treatment, also known as biological treatment, is very effective at removing dissolved and suspended organic material. So effective that that it can remove up to 95% of all organic material in the effluent. So what happens in this stage is these microorganisms are added to an aerated tank. And the microorganisms' goal is to eat all of the organic matter and turn it into cell mass. So here we have a little bacteria, and he's just vibing out in this tank, having a good time, all the food he needs, all the oxygen he needs to decompose, and he does a lot of good for us. So let's take a closer look into this process. So there are two main ways you can get rid of organic material. And the first one we're going to talk about is a suspended growth system. And so here you have an environmental engineer checking out some activated sludge. And so what this is, it's a tank of your bacteria and effluent solution, all mixed up together with a bunch of oxygen pumped into the tank to promote aerobic decomposition. And so these microorganisms are breaking down possible harmful organic material, and they're reproducing in the process, creating more of themselves and just ultimately reducing the biochemical oxygen demand in the tank, which is good because we don't want any living organisms or possible parasites living in there. So a low BOD is good for wastewater treatment facilities. The second option that you can use for biological treatment is an attached growth system. So how these work, on the left, we have a trickling filter, and on the inside of these basins, you have a filter media. And so what happens is the microorganisms grow on the substrate inside of these tanks, and the effluent is then allowed to drip through the medium in the tanker. And so similar to the activated sludge process, the microorganisms are just going to eat up all of the organic matter inside of the wastewater. On the right, we have a rotating biological contactor. And what that does, it's very similar to the trickling filter, but it's on like a rotating rotisserie, like a chicken sort of. And it just dips these filter mediums into the wastewater. And it does a similar job of growing and eating organic matter. So both systems are very effective at reducing organic matter in effluent. So after you use all of these biological treatments, you have to get rid of the activated sludge or some of the microorganisms that might have died in the water. So what happens is the water is pumped into a second clafer, which you can see in the background here. And the water is allowed to settle, and the microorganisms or activated sludge is then taken out of the tanker and sometimes pumped back into the aeration tank. So you can kickstart this process again and clean more water. But most of the time, the sludge is sent to landfills, or it can even be used as fertilizers after it's treated with various methods. So that was secondary treatment. Now let's talk about tertiary treatment. And that involves disinfection, which is kind of a little bit in between. Sometimes it's used before or after tertiary. So it's a kind of a middle ground for both, but we'll talk about it regardless. So tertiary treatment, also known as advanced treatment, is not always used in water treatment facilities. The main goal is if you're going to pump the water into a place like a river or a lake, and you can't have some of these nutrient-rich components in the water. And also if you're going to drink the water. So you have to make sure that you kill all of the pathogens that could possibly be in your effluent solution. So the first two that were processes that we're going to talk about are chlorination and a UV light system. All right. So The disinfection process with chlorine involves um, adding your wastewater solution to a chlorine contact tank. And so you're gonna allow the water to sit in a hydraulic detention. So basically, you're just leaving all of these pathogenic organisms in jail and you kill them all. And so after the jail time, you have to remove the chlorine in the water because it's highly toxic to both humans and all living organisms that could live in the environment. So you add sodium bisulfite and sulfur dioxide, and you can effectively remove the chlorine. But a lot of people are not very happy with this method because there's always a little bit of chlorine that's left in the water. And so this can be harmful to different aquatic environments. So an alternative is the use of UV light radiation. And so what you see here on the bottom of the slide are channels of ultraviolet lights, and the effluent is pumped through them and it deactivates the organisms, which effectively just kills them, and they just cannot spread any pathogens to humans. And it's a very effective way that doesn't use chemicals but uses a lot of energy. So they both have drawbacks and their pros. So so an alternative to disinfection is nitrification and denitrification. So your typical wastewater is going to have a lot of ammonia in it, and that's toxic to aquatic organisms and all types of plants and fish. So in the process of nitrification, you utilize nitrophers, which are autotrophic nitrifying bacteria. And what they're going to do is they oxidize the ammonia. And when you oxidize ammonia, you create nitrites and nitrates. And both of these compounds are less harmful to the aquatic environment. And additionally, you can use denitrification, which utilizes facultative anaerobes, which are known as denitrifiers. And what these guys are doing, similar to what we saw in the activated sludge systems and some of the other different methods, is they create energy, ATP, from aerobic decomposition. So both of these systems are going to utilize aeration and some type of pumping of oxygen. So in the denitrification step, you are ultimately converting nitrates to nitrogen gas, which can then be taken out of the wastewater and create a clean product that doesn't affect ecosystems and cause algae blooms and all sorts of um, environmental damage. So I want to talk a little bit about the future of wastewater treatment. So on the left, you see a wetland, and wetlands provide a lot of environmental services for humans. They prevent erosion and flooding, and they also provide natural habitats for some of the most important organisms on the planet. So what humans have done, not very commonly, but are implemented in some areas, is the construction of wetlands to help mitigate the effects of water pollution or possibly clean our wastewater. So this is a great way to utilize plants in an ecosystem service to absorb toxins in our wastewater. And we're also providing natural habitats for lots of different species. On the right, we have a gray water system, which is just a different function of piping where you utilize your wastewater that isn't quite dirty from showers or possibly the dishwasher, and you grow produce or water your lawn with it. And this reduces the amount of water we use and also helps clean and recharge aquifers. So that's all I got. Check out the sources. Thanks for listening.